Now that you know how to identify chiral centers, let's take a look at its significance when they are looked at in a mirror. If you take a molecule that is not chiral, and as you can see, this molecule is the same as the one here drawn on the board, and you look through a mirror at what would be its mirror image, and here we have the model of that same molecule. If you take the two molecules and put them together, they are superposable. Every single group matches up. Now let's take a look at a molecule that is in front of a mirror that has a chiral center. As you can see, we have a molecule that has 4 different groups attached to a tetrahedral carbon and has no planes of symmetry. Therefore, this is a chiral center. On the other side of the mirror, we have its mirror image, and as you can see, it also has 4 groups and is a chiral molecule. If you take the model for the first image and the model of the second image and you superpose them, you'll see that the two molecules only superpose 2 groups and the other 2 groups are not superposed. Therefore, this is a non-superposable mirror image known as an enantiomer. When drawing stereoisomers, it is important to keep the connectivity between the atoms of the 4 different groups attached to the carbon the same. There's 2 ways to do this. The first way is to hold one group steady and rotate all 3 of the others. If you move A to B, B to C, and move C to A, you end up with this structure. If you look at the model, you can see that A, B, and C are lined up on this, and if you rotate it, you can end up with C, A, and B. Now, this can be done with any bonds so long as you hold one group fixed and rotate all 3 of the others. That way, you can get the drawing that you desire. One more way to maintain the connectivity of a stereocenter while drawing stereoisomers is by interchanging 2 sets of groups. On this structure, if you interchange A and B, and you interchange D and C, you make this structure. As you can see from the model, A and A are lined up, B and B are lined up, C and C are lined up, and D and D are lined up. If you flip this model around, you'll see that you've created the same molecule by interchanging 2 sets. However, if you were to change only one set, you would end up making the enantiomer. As you can see, this model lines up with this structure right here, as well as this model lines up with this structure up here. However, these 2 structures are non-superposable mirror images.